With all the AI hype flying around, this might sound a bit controversial, but honestly, AI wouldn't be the first tool I would reach for when building a product. In my career, I have launched multiple AI products that have reached hundreds of millions of users. I also got a PhD in machine learning from the University of Cambridge, so clearly I like technology, I like AI, and I also understand what happens behind the curtains. So with all that, AI still wouldn't be the first option for me. Here's the thing, products shouldn't be complex just to show off. Start simple, nail the basics, benchmark, and only add complexity when it actually helps to solve a real user problem. It's not about building something fancy, it's about building something that works. As someone who is working closely with product managers as well as mentoring up-and-coming AI engineers and people who would like to transition into AI space, I often get asked, so when should I actually be using AI in my product? And this is a critical question. I have a checklist that I run through before deciding if AI is the right tool for me. In this video, I break it down into 8 simple questions that you should ask yourself before diving into building an AI-powered product. So what are they? First, is the problem a good fit for machine learning or AI? Second, do you have enough data and is your data of a reasonable quality? Third, do you have enough resources, both time and budget, for multiple iterations? Do you have enough budget to not only build the application, but also to maintain it over time? Fifth, how critical is it for you that your model does not discriminate against your users? Sixth, how critical is it for you that your model has a 100% precision and accuracy? Seventh, how critical is it for you to understand how your model arrives to the conclusion? And finally, does your application need to run in real time? These questions can save you tons of money, tons of time, and also energy. Is the problem that you're trying to solve suitable for AI? Let's talk about where AI is actually needed and where it's an overkill. At its core, AI and machine learning is just a fancy way of saying, let's learn some patterns from the training data so that we can predict some unseen stuff. And some of those patterns can be simple enough for us not to need to use complex neural networks. For example, let's think about predicting the next sunrise sign. We don't need large language models for that. We need a set of simple physics rules. At the same time, some problems might be a bit too complex for current models. Think about machine translation, translating a novel from one language to another. For that, the model needs to have rich world knowledge about the time and context of the time when the novel was written, and also really deep knowledge of the languages. And this might be a bit too complex at the moment. So what's the sweet spot? First of all, narrow the scope. Be specific about what you're trying to solve, and then figure out if AI is the right tool for this specific problem and not just tech for the tech's sake. Do you have enough data and is your data of a reasonable quality? The biggest blocker to developing AI-powered products, it's not compute, it's not algorithms, it's data, and more precisely, high-quality data. For many real-world problems, the data just does not exist. For that, we have a huge market of tools that help us label the data, such as Amazon Mechanical Turk, where you send a bunch of examples and workers label the data based on your requirements. At the same time, you might think, well, it's a bit too expensive, it's a bit too slow, I might as well use the data from the web. But it also comes with a set of challenges. For example, the data on the web is very noisy. You need to think about how to clean this noise out of the data so that it contains only the things that you would like it to include. Data rights. You are not allowed to train on all data. You might consider whether the dataset that you're collecting does not violate any of the permissions. And finally, data bias and balance. Any imbalance or any bias that you have in your data would seep through into the model. Perhaps let's think of a simple example where you would like to train a model that would tell cats from dogs. And in your data set that you have collected, you have 1,000 images of cats and just 10 images of dogs. The model would likely learn that, well, just let's call everything a cat, because you just don't have this representation of dogs in your data set. Now let's consider that you have a balanced data set of cats and dogs, but all your cats in the data set are white and all the dogs are black. The model might come to a conclusion that, well, everything white is a cat and everything black is a dog. So you might consider improving the balance of data also within each of the subclass and providing enough versatile data within each of the subclasses. All those problems sip through big models as well. So they are not only relevant to those toy examples. Think about large language models that are trained on one-sided articles. They would perhaps be one-sided as well. Models that are missing the data on specific topics or not trained on minority languages would not be able to speak those languages or talk about those niche topics. So before you jump into building your big model or application that is powered by those AI models, think about whether you have enough data to do the right thing. Can you afford an AI-powered application? And here I'd like to separate the costs into two. One is building cost and second is maintenance cost. Building cost has three major buckets. One is people, second hardware, and third is the data. Machine learning isn't just plug and play. Even if you decide to rely on APIs from OpenAI and Google, you still need to have engineers who have experience iterating on those models, fine-tuning them, and also verifying if they are ready for production. If you decide to train your own models, you need engineers with a very, very specialized skill set who can train those models, put them in production themselves. And those engineers are not coming cheap. An average salary for a machine learning engineer in the UK at the moment is £70,000 per year, and top-tier talent costs even more. So think about it before you start building your application. Second is hardware. Machine learning models need to be trained on a very specialized hardware. Would it be GPUs or TPUs? And those processors cost, and they cost a lot. And perhaps you've seen NVIDIA, who has earned lots and lots of money from the demand for its hardware. And while early stage startups can be hooked by large corporations with free credits, once you run out of them and once you become an established business, you need to start paying, and the bill would grow very, very quickly. Finally, data. Unless you have a rich, clean data set laying around, you'd need to collect it yourself. And if we think about Amazon Mechanical Turk, a simple one-click task would cost you around 5 cents. And a million example data set would cost you around $50,000. If you want something a bit more complex with the same amount of data, you can easily pay a few hundred of thousands of dollars for just this data set. What many people forget is that building the model isn't the end. You still need to maintain it once it's live. Data changes, user behavior shifts, and so your model needs to keep up. For that, you need engineers who would be constantly monitoring how your model performs and updating it if necessary. Your models run in the cloud typically, or on some hardware for which you need to pay as well. And as your business scales up, so does your compute bill. And this would happen really fast. There is a tricky balance to strike that you need to think about. If you don't order enough resources, your users might end up waiting for a bit too long for the response from the model, or might face timeout errors. On the other hand, if you order too much, you might end up burning the cash. So this is a very tricky balance to strike, and another reason why maintaining an ML system is far from just set it and forget it. In short, ML isn't just expensive to build, it's also very expensive to run. Do you have enough time to build this AI-powered application? Many of the solutions aren't available out of the box, such as those that are provided by Google, Amazon, Microsoft, and that means that you need to collect the data, build the testing, training, maintenance pipelines on top of it. And from my experience, setting up a very simple application that is powered by AI requires roughly 3 months. You need to have 1 month for collecting the data, you need 1 month for building the training pipelines, and then you need a month to have a few iterations before you reach this production quality. This also reminds me that deployment process or building process is an iterative process where you add complexity at every stage, meaning that at some point this complexity needs to be maintained. Depending on the application, there could be dozens of iterations before the product actually reaches the market. Is it important for you to understand how AI has arrived to a conclusion? For some non-life-threatening applications, it might not be critical, yet it would be useful. For example, think about drug discovery. If we know how the algorithm has arrived to a certain form of a drug, it could hint us into patterns that we need to look at if we want to make further discoveries. For life-threatening applications, think about law or healthcare, we would need to know how exactly we have arrived to a certain conclusion so that we can backtrack in case something unforeseen happens or verify if the arguments are rational or not. This might not necessarily discard AI as a potential tool for your application, but might limit your options in terms of the models that you can use. Could your product be making decisions that would be discriminating against the end users? The infamous Twitter bot that within a glimpse has turned into a racist prick is a good, but a very rare explicit example of when the model took the wrong turn. Most of the biases that those models have are very latent, meaning that it's very hard to detect them. Some of the biases are benign. For example, imagine an AI chatbot that has learned to be nicer during afternoon times than morning or evening. This sounds not as serious as, for example, a chatbot that learns to be nicer to one gender than another. Typically, all those biases are pointing to a huge problem in your training data. To catch those biases early, you need to know what is in your data and set up extensive testing pipelines before you launch your product into real world, and also have the tools that would be monitoring what is happening in production. How critical is it for your product not to be 100% accurate or precise? Many AI models are probabilistic, meaning that for the same input, you are not guaranteed to obtain exactly the same output. And while for some applications, this might be a plus, for example, text or image generation, you'd like to have a set of versatile examples that your model can generate. While for other applications, such as, for example, face recognition or fraud detection, you would like to have this 100% accuracy and 100% precision. When building AI-powered applications, you need to think about this margin of error. How much error you can allow before it starts to affect your users. And for that, you need to set up very extensive testing pipelines with huge amount of versatile data that you run through. Ideally, this data also needs to be real-world data so that you understand how your model behaves under different conditions. And you also need to make sure that you test not only one single block, but also the system as a whole, because some of the errors tend to propagate. Does your AI product need to run in real time? Well, when it comes to machine learning and AI, there's always a balancing act between speed and accuracy. Heavier, larger models that tend to process your input much slower, they tend to perform much better. Whereas smaller and faster models are very often much less accurate. So when thinking about your AI product, think about what is required in terms of speed. Some of the examples where speed is so important that machine learning solutions would be an overkill are, for example, high-frequency trading or computer graphics. You just simply don't have time for those larger models. Another thing to consider is where you'd like to deploy your model. If it's a mobile device, you might think about, well, can I actually afford, given the constrained resources of a mobile device, to port a large model that I have developed or I want to use for my AI product? Bottom line, machine learning isn't always the right tool, especially when speed and computational resources are constrained. So is AI powerful? Absolutely. Is it always the right choice? Absolutely not. So before jumping into deep learning, massive models, complex pipelines, ask yourself a question. What am I trying to solve, and is AI the right tool for it? Sometimes simplicity wins. Sometimes it's rules, not regression. Remember, great products are built not on hype, but on clarity, focus, and solving real user needs. If this helped you shape how you think about AI products, hit this like button, subscribe, and comment below about the product that you are trying to build. I'm mentoring, so if you'd like some help with your product, or you are lost in your career path, links are below. Thank you very much.